Okay, this is part 5 of whole numbers and basic arithmetic, and we're going to continue with exponents. So if you were asked to write, say, 64 as a power of 8, what you would do is you would, so 64 as a power of 8 would equal 8 squared. Alright, now if I said write 64 as a power of 2, then you would use some basic deductive reasoning and say, okay, well, 8 is 8 squared is 8 times 8. Alright, and 8 times 8 is 2 to the third times 2 to the third. Alright, so then that would lead us to see that 64 written as a power of 2 is 2 to the 6th, like so. And if we looked at, say, 256, so let's put that down here, 256, and we say, write that as a power of 16. Well, 16 times 16 is 256, so 256 squared, 16 squared is 256. Alright, now if I said write 256 as a power of 4, well, 16 squared is 16 times 16, and 16 is 4 squared. So 4 squared times 4 squared, which is 4 to the 4th. So 256 could be written as a power of 4, and it would be 4 to the 4th power. Alright, let's make some more room. Okay, so we just kind of saw this, but I'm going to show it to you again. Say we had 2 to the 5th times 2 to the 6th. Oh, sorry, 2 to the 6th. That's going to equal 2 to the power of 5 plus 6, or 2 to the power of 11. Okay? So when we times an exponent, something in exponential form, so that has the same base, 2 is the same base, then we plus the exponents. So 5 plus 6 is 11. Another example of this would be 6 to the 10th times 6 to the 13th. Well, that's going to be 6 to the 23rd. Let's take a look at another example, and say we have 16 squared times 16 to the 0 power. Now I already told you that 16 to the 0 power is 1, so 16 squared times 16 to the 0 power is really 16 squared times 1, which is just 16 squared. Okay, let's make some more room. Alright, so again, we're sticking with exponents, and we're going to go over what are perfect squares, okay, and what are not perfect squares. So if I give you a number of 36, is that a perfect square? Yes, it is. So that is 6 squared, so yes. What about 27? Is that a perfect square? That's a no, not a perfect square. Why? Because 27 equals 3 times 3 times 3, or 3 cubed. Okay? What about 144? Is that a perfect square? The answer is yes, it is. Why? Because 144 equals 12 times 12. Or, oops, 12 times 12, or 12 squared. Let's take a look at one more example. Say we have 56. Is 56 a perfect square? No, it's not. The closest that we can get to having two numbers that are almost the same for 56 is 7 times 8. So it's not a perfect square. Okay, let's take a look at square roots. So let's make some more room. All right. So 256. What's the square root of 256? It's 16. All right, it's not 16 squared. That's a no-go. It's just 16. All right. Okay, and then let's take a look at 225. The square root of 225 is 15. Okay, just 15. And how about 324? Well, that's the square root. The square root of that is 18. Okay? So 16, 15, and 18. It's not 16 squared, it's not 15 squared, it's not 18 squared. It's just one number. When they're asking for the square root, they're asking for one number. When they're asking for you to see if it's a perfect square, then they're asking you to see what number squared equals a perfect square. Remember, like we just showed you 36? When they ask you if that's a perfect square, yeah, it is. Okay, so explain, prove it. Well, that's 6 times 6, or 6 squared. But when they're asking for the square root, they're not asking you for 6 squared, they're asking you just for 6. Okay? Okay. Now let's take a look at perfect squares and perfect cubes. Okay, so is 26 a perfect square or a perfect cube? No, it's neither. What about 27? Is that a perfect square or perfect cube? Yes, it's a perfect cube. Not a perfect square, but a perfect cube. 900. Is 900 a perfect square? Indeed it is. 900 is a perfect square of 30 times 30, or 30 squared. What about 125? Is that a perfect square? No, it's not. But what it is a perfect cube. It's 5 cubed. All right. What about 729? Is that a perfect square? It is. What else is it? It's also a perfect cubed. So first, let's do the cube. The cube is 9 cubed. And the square was 27 squared. Okay? All right. Now let's take a look at order of operation. Order of operations. Let's make some room real quick. All right. So let's take a look at a problem. So we say we have 24 divided by 3 multiplied by 2 plus 5 squared minus 10. Let's look at another problem. 7 times 9 plus 5 times 6 plus 3 plus 2 squared minus 1. Okay, so order of operation tells us to do what? Parentheses, exponents, multiplication, division, addition, and the subtraction. Please excuse my dear Aunt Sally. So in this case, we need to do what's in these parentheses first. But before we can add these two numbers, we need to do the exponent. So that is 25. Then plus the 2. And that's going to be 27. And minus the 10. And by the 3. Right. Like so. Now, some people might want to do the multiplication first. Well, that's not what they want you to do. You need to do the division first. You need to work from left to right. When you can, you work left to right. If there's things that interfere, like these parentheses, we do those first. But then, if you can revert to left to right, you do it. So, 24 divided by 3, that's 8. Times 27 minus 10. Well, I'm going to break that up and use the distributive property. So 8 times 27 is the same as 8 times 20 plus 7, minus the 10 over here. And that right there is 16, plus the 0 is 160, plus 56, minus the 10. Okay. And this is 216 minus the 10, so it's 206. Okay, let's take a look at this one first. So we do parentheses first and exponents. So right here we have parentheses. So we have two parentheses. We can do this one if we want to first. And then we can do this one next. 3 plus 2 squared, that's 4. So 3 plus 4 is 7, minus 1, and then now we can do the multiplication. 7 times 9 is 63. 63 plus 30 is 93. Okay. And then we're going to plus the 7. And then we're going to minus the 1. So that's 100 minus 1, so it's 99. And that is order of operation. Okay. I think we're going to take a break, and then we're going to start again in just a little bit.